Good morning, everyone. Um, I'm sorry for the delay. Uh, I had some connection problems. We're going to start with our lesson. Uh, since we today we have to finish. It's not really a long, I can say a long chapter. The chapter which we are starting today, so it's possible for us to finish, and they are the things which you guys already know. So I'll be just, it will be just like remind, I'll be saying things which you already know is just like reminding you the things which you did in your secondary. So before I begin, uh, I'm going to pray. Shall we pray? Our dear Heavenly Father, we come before the throne of God, asking you to be with me, oh God, and impact wisdom in me, oh God, so that I might be able to teach them and impact the understanding into my students, oh God. In the name of Jesus, I pray. Amen. Without wasting any time, we're going just to dive into our lesson for today. Yeah. I hope you can get me clearly.
Wait.
Are you able to see my sharing?
Yes.
Okay. So today we're going to talk about la charge and la force electrostatic. So basically we're going to talk about what is the charge. The charge. You know, there is positive and negative charge. What is the force? This force electrostatic. Yeah. Basically, when you see the word static, it means something which is not moving, static. Something which is not moving. So we're going to look at in a simpler term, we're going to look at it. Start at the word for net. For you to be to understand electricity, you have to know where it's coming from. Each base is really important to know where it's coming from. And when you know where it's coming from, you'll be curious to know more how this electricity, which we have, really work. Then after that, we're going to look at the charge electric. When I talk the charge electric, the positive and the negative charges, those are the things which we're going to look at. Then after that we're going to look at the force electrostatic. So the force electrostatic is what force when you have two charges or when you have two components, what force exists between them? Is it a force which is separating them? You know, if you have two charges which are equal, you have a repulsion where there's a separation of forces. If you have two charges which are opposite, you have attraction. So those are the things which I can say in a nutshell, which we're going to look at. So the first thing is electricization. So I'm just going to do it a bit fast, but if you have any questions, don't stop me. You can stop me. Sorry, you can stop me and ask your questions. Ask your questions where I don't understand. The most important thing is you understanding. The most important thing is you understanding. So I'm going to begin with our new chapter, which is chapter 2. So chapter 2, it begins with the origin de l'appellation électricité. So it's just the origin. Where did this name electricity come from? This is the origin de l'appellation électricité. So so we're going to look at where did electricity come from. So before we look at that, there's this part which is not really, I can say, important. It just tells us that la interaction électromagnétique est une des quatre interactions fondamentales. So here they just trying to tell us that there are four fundamental interaction, which are in this world, and these four interaction, like when I say interaction, is uh, the interaction between two atoms or compounds or what, they are about four, which I can say, which are defined in this world. But for us, we're just going to look at the electricity. Yeah, interaction and electromagnetic. So here they're just telling us there is just some, those four interaction. So we have interaction faible. So this part is not really important. It's just, yeah, just telling you the form. There's interaction faible. So interaction faible is the interaction in such a way that I can say is when très meaning is very short. This is the interaction between radioactive what yeah, this is interaction between what reductive element, reductivity, yeah, reductive element, and this interaction actually is very feeble. Yeah, it's very feeble. For you know that the radioactive element, uh, they like they are when you get a radioactive element, you can easily break it. Yeah, you can easily break it simultaneously. Those, if you remember physics, to other smaller atoms. Yeah, you can easily break it to other smaller atoms. So you see there that their interaction, their their what their interaction is very feeble. So if you see here, you see about 10 to the power negative 18 meter. So one of the interaction which we have, which you like I said, which we have in this world is interaction what feeble. Then from there there's interaction forte. Interaction forte is interaction which involves it is also short. Court, it means short, but it's interaction which involves the noyon, which you know that the noyon is made up of the what uh, the electrons and the protons. The noyon is the nucleus. Yeah, I think you did in your chemistry. Noyon, when you talk about noyon, is the nucleus, and the nucleus is made up of what? Protons and the neutrons. Yeah, so we see there that uh, uh, for you to make a what? A nucleus, I think you learned this in those who are doing uh, atomistic, yeah, chimia atomistic. You learned that when the protons and the neutrons, they are coming together, there is some energy which is released, and there's they bond and they form a nucleus, which we call a nucleus. And that interaction between the protons, the what, the neutrons is an interaction forte, which is also cold, which is also it happens at a very short period. Yeah, yeah, but it happens at a very short what period. Then there's also interaction electromagnetic. So when we talk about interaction electromagnetic, is the interaction, there's the electricity, there's electro, which is the electricity, and magnetic, which is the magnetism part. So when we talk about interaction for electricity, you know that there's a positive and the negative charge which they interact. So one example is the cohesion of the atom. Cohesion of an atom, when I say cohesion, it means the coming together, yeah, the coming together of an atom. So you see there that the cohesion of an atom, you need the electrons, which are negative charge, and the protons, which are positive charge. Yeah, so you see that there will be an attraction between the protons and the electrons, and that's what forms an atom actually. Yeah, because you know that neutrons, they don't have any charge; they are neutral. the neutrons. So it's only the protons and the electrons which are they attract each other. Yeah, so this one is is one of also the interaction. There's also interaction gravitational. The interaction gravitational is actually the cohesion of the galaxies, where you form the galaxies. Yeah, so basically those are the sum of the forces, the interaction which we can find in the world, the four fundamental interaction, but we are not really interested on those. So yeah, so it continues saying here that it continues saying here that électromagnétisme est né grâce au rapprochement de l'électricité et du magnétisme. So here is saying that electromagnetism, if the bulletin here is saying that électromagnétisme est né grâce au rapprochement de l'électricité et du magnétisme. So here just saying that uh, the word electromagnetism or the phenomenon electromagnetism is just made up of two words, which is electricity and the magnetism. So is forming a what? Basically, electromagnetism is the relationship which is formed between electricity and the magnetism. What relationship is there? So first of all, to know the relationship, you have to know what electricity it is and what is magnetism. So if you know what the magnetism is and what electricity is, then now you know the relationship which is there. So we know that electricity is defined by the positive and the negative charges. There will be some movement of the charges sometimes. And the magnetism is North Pole, South Pole, those samples samples repel and opposite poles attract. So north, south pole. So we're going to look what relationship is there between electricity and magnetism. But in this topic, we're just going to see the electricity part. The electricity part. What is electricity and the charges, those things. Then it continues here saying that yeah, so it continues here saying that d'un seul coup, on s'intéressera à la partie électricité uniquement. So it's just saying that in this part, we're just only going to be interested with the electricity part. Yeah, electricity part. So that's just I can say an introduction. Yeah, that's just an introduction, just talking about the four interaction fundamental. Yeah, but those are not really important. They just they are just to give you some knowledge about the four interaction fundamental. Yeah, so now we're going to begin with our topic. I don't know if there's any question on the first part. Okay, okay. Yeah. So if there's no, since you just that one, it was just an introduction. So now we're going to begin with the actual lesson now. So origin de l'appellation électricité. So where did this term electricity came from? So électricité vient du mot électron, qui signifiait ambre en grec. So the word electricity, it comes from a Greek word which is electron, and this word it signifies an ambre. I don't know if you know an ambre. An ambre is is a rock. Yeah, it's a form of a rock which is transparent. Yeah, yeah, it's a form of a rock which is transparent, and it's formed from the fossilization of what the uh, when of a tree, which means when a tree dies, it when a tree dies, it what it after some many years, it will what it will undergo under fossilization. Fossilization is just decomposing of something. After decomposing of something, you form something which is like a rock, and this rock is transparent, and it has the name of what amber. So this word electricity comes from the word electron, which signifies amber. So how did they really discover electricity? So here down here, you see that it says that the phenomena de l'électricité est observé lors de l'attraction d'un paille par un morceau d'ambre frotté. So what they did here, what it means here is they got the same rock, they fraught meaning you what you in English, the word in English has gone. Frotte meaning you are somehow I can say you are when you are scrubbing something, when you are causing friction, like you have a flat surface, then you are close you are doing like you are scratching that surface, like you are, I can say, yeah, that's the best term in English, like you are making a friction down, making the friction. So what they did is that they got that rock, they made some, like they started rubbing it on the I can say on the floor or on any surface. They started rubbing it. Yeah, and after that they tried to bring this rock near some straw. I can say uh, if those who have done farming before, or yeah, I think most of us who have done that. The maize, I can give an example of the maize, or even grass when is what is after, like in hot season when it's dry, you know how it looks like. Yeah, when the grass is dry, it there are those too much small things, like yeah, they call them too much straw. Yeah, those things. So they try to rub the rock and bring the rock near to this straw, and they found that there was some kind of attraction. Then yeah, they found that there was some kind of attraction, and this thing made the people to be curious about what really was causing this attraction, and that's where uh, the knowledge of electricity started from. So it started from a rock, which they, like, by accidentally, when they rubbed it, they found that it can attract some things. Yeah, it can attract some things. So that's where the knowledge of electricity started from. So from there, I think these I can say from there they did some experiment, a lot of experiment, to see to really know what's happening, because for them, like, at first when they had discovered this, at first when they had saw this, like, for them they couldn't really understand what is really happening here. Why can, after we rub something down, we see some attraction? What's really happening? That was the question which they needed to solve now. So after there, uh, they did some experiment, I can say. So they did some experiment to see what really was causing this attraction. So they did one of the experiment which they did is electricization par frottement. So here, basically, this chapter basically is about history. Yeah, those who love history, you love this chapter, because it's about the history, about how did this same electricity which we see, which we use, which now it has become something which is to some is something which you cannot live with, because it has become something which uh, is part of our daily life. Like at night, you know, you have to have some electricity, all those things. So now, yeah, so they did some experiment, and this experiment was electrization par frottement. Frottement is rubbing. So first of all, they got a verre. Verre is in English is a glass, a rod glass. They got it. Then after getting it, they scrubbed it. They rubbed it down on the surface. Then after rubbing it down on the surface, they this is the first experiment here, which you can see. They brought it near to some pieces of, I can say, papers, some pieces of small papers here. So what they observe is that after they brought this glass, after they brought this glass near to the papers, they observed that the papers were what? Were being attracted to this glass. So for them, it was also a one that they couldn't know what really was happening. So from there, they said, for a glass, we have seen an attraction. There's attraction when you use a glass. Then from there, they went to an ebonite. Ebonite is basically a plastic. Yeah, a plastic. Yeah, ebonite is a plastic, a rod which is made of plastic. So they rubbed a rod which is made of plastic again on the surface, and they brought it near to the papers, and they saw that there was an attraction which was also taking place here. And it was the same thing which they observed, the same thing with the thing which they observe with the glass, the rod glass, is also the thing which they observe with the ebonite. Then from there, they went to the cuivre. Cuivre is basically copper. So they went to cuivre, they rubbed the cuivre, they tried to do some, they tried bringing it near to some papers, but yeah, they found that there was no attraction. Nothing really happened with cuivre, and with that, it also brought some question. What really happens when you get a metal, you scrub a metal down, then you try to bring it near to the papers, but nothing happens to it. Then from there, they got the combination of a quiver and some bois. Basically, it's a wood and the quiver. They had put it together. Then they scrubbed at the end of the quiver, and they saw an attraction. So they now came to a conclusion. They now came to what? A conclusion, because they saw that when they are using non-metals like verre, which is glass, ebonite, which is plastic, and when they combined with the quiver and the bois, a quiver is copper, um, then bois it was wood and non-metal. So when they combined the metal and the non-metal, they also saw it what interaction. So they now began to interpret these changes. So that's where here you are seeing that there is the interpretation here. So we see that in A and B, les charges restent localisés sur les pattes frottées. Les verres et les bonites sont des isolants électriques. So here they're saying that what happens when you rub the verre and the ebonite. So when you rub the verre and the ebonite, you form actual charges. When you form a charge, what happens is that that charge doesn't move. It's at uh, a stationary point. Yeah, there's a charge which is formed in a verre, but that charge you add doesn't move. So when you bring it closer to papers or what, you see that there's an attraction because there are charges at the end of the part which you have scrubbed. Even with ebonite, when you scrub it, you see that there are charges which are formed at the end, but these charges doesn't move. They're in a form which is what is stationary. And when you bring it closer to some pieces of papers or of some wires, you see that there will be an attraction. then they went to see now. See, they say that les charges se déplacent dans les métaux et s'écroulent vers la Terre. Les métaux sont des conducteurs électriques. So isoelectric, they are it's just bad conductors of electricity. Then conductors of electric, these are the one which can allow electricity to move in them. So we see here that the metal, after they had scrapped the metal, don't forget that there's a person who is holding this metal. So after they had wrapped the metal, there are charges which are formed quite all right, but these charges are quickly moved to the hand of a person and into the body of a person, and it goes down to the earth. So you see that there will be a movement of what charges immediately. The charge what is moved, and there's what I can say there will be the charges which uh, uh, are limited. For example, if you have got a positive which is more than a negative, you see that the negative from the hand of a person will go to the end here, so that they have an equal number of the positive and the negative. And if you have equal number of positive and negative, then I can say the material becomes it won't be the material becomes I can say it can't attract the papers, the wires, because the material becomes not a conductor, or I can say not a what it becomes neutral, which means the positive and the negative. The best term is it becomes neutral, where the positive and the negative becomes equal. And when it becomes neutral, it is not magnetic, because the equal number of positive charges and the equal number of what negative charges. So there will be no attraction. So that's what happens. Then on D, they observed that there was an attraction, because if you have seen here, there is wood and there is a conductor. So quiver, not quiver, you should note that quiver is a conductor. So each time when you scrub a conductor or you rub a conductor, there's movement of the charges. But here there's bois, which is wood, non-conductor. It means that the charges will just rest here. They won't move anywhere, because this is a what? A non-conductor, and you will see the attraction. So I don't know if there's anyone with any question here, but I think there are simple things which I think when I'm talking, you even relate to what you did in your secondary school. So I don't know if there's anyone with any question before we go to another chapter.
Yeah, repeat your explanation on C.
And what on what?
The C, the diagram C.
Okay. So on quiver, I was just saying that since quiver, which is copper, a metal is a good conductor, and a good conductor, basically, when you rub it down, you form charges. Quite all right. You form charges. It will be charged, but what happens is immediately when you form charges, those charges will move in this metal, and it will go into the hand of a person, and into the earth. So we see there that there will be if you form these charges. When I talk about the charges, it means when I talk about forming charges, it means one of the two charges is more than the other. For example, if you have positive and negative, you know that charges have got positive and negative. When you scrub it, for example, you can have the positive, which is more than the negative. There's no equilibrium between the two. So what happens is, since the quiver is a what is a conductor, it will search how to make these charges equilibrium. And a conductor, it allows the movement of what charges to move. So you see that those charges will move into the hand, and from the hand you see there will be those charges will move into the hand, and It will go to the earth so that it has what it can lose some of the charges and to have the equal, with a goal of having the equal numbers of what positive and negative charges. And we know that if the negative charges and the positive charges are equal, the material becomes non-magnetic. The material can't attract anything. It can't attract anything. So that's why you see that when you bring the copper metal near the pieces of metal or the papers, you see that there'll be no attraction really. There'll be no attraction. So I don't know if it's clear. The one who asked the question. The one who asked the question.
Wait.
Okay. Okay. So basically, those are that's I can say one of the way of one of the way they discovered of making what electricity. So at first they thought that when you make a charge, it would just rest, but a metal proved them wrong in such a way that they saw a movement of charges, and when they discovered that the charges actually can move, that's where now the idea of the electricity, the electrostatic, which is the movement of the charges, it came about because they saw there's something which is happening here because we have done the same procedure for all these metals, but why copper is not attracting? So those are some ways in which the development of electricity started from. So from there we see that we can define two types of electricity, the type, the electricity. So so we see here that we have two type of of electricity. There's they when they were when they are trying to define these two types, they tried to make up an experiment in such a way. In this experiment, they got ebonite and they got also the verre. So what they did is the ebonite, they what they did is they got the two ebonites which have been rubbed. One they had put it on the water on the stand, and the other one the someone was holding it. So what they did is they tried to bring the two ends which were charged together, and they saw that there was a repulsion between these two ends, and they discovered that they said that they discovered two types, which is electricity resonance. Yeah, electricity resonance, which is à laquelle un signe négatif est attribué. So they say that ebonite, which is plastic, it has it has electricity resonance. And when I talk about electricity resonance, it's basically is ebonite is where they discovered that ebonite was negative charge. They said I can say that's where the charges came in when they tried to first with the ebonite. They found that there was a repulsion between the two ebonite, and they said they gave this ebonite a negative charge. Yeah, they gave the ebonite a negative charge, and after that they got a glass which is verre. They got a glass which is we can call this one electricity vetrus. Vetrus is basically the using of a glass. When I say electricity vetrus, it's the using of a glass. When I say electricity resonance, it's the using of a plastic. Yeah, that's what you should just know. And yeah, and when they got the two plastics, one charged, the other one which is not charged, they rubbed them, and they tried to bring these two pieces together. They saw that there was a repulsion which was happening, and they said, okay, for this one, we're going to give it a sign which is what? Negative. And when they got a glass, which is verre, they tried the same thing also. When they brought it together, they saw there was a repulsion also. And they distributed to a verre. They said the verre is positive. Yeah, they attributed the sign positive to a verre, and from there they tried the verre and the ebonite. They tried to bring them together, and they saw that there was an attraction between these two, and this made the assumption, because they never. I can say it was just an assumption. I think you know what an assumption is. Assumption is uh, having a belief of something which you know is you are not really sure. Yeah, you are having a belief in something which you are not really sure is uh, how can I say it? Is something which uh, is is not determined. It's something which you just guess. I can say so. So they just guess for Ibonite. Ibonite, if they wanted, they would have given it a sign which is positive, but they just gave us they just gave it a sign which is negative with the assumptions, and for Ver they gave it a sign which is what? Positive. And when they tried to bring these two, the plastic and the glass together, when they tried to bring these two, they so that there was an attraction, and this brought their assumptions to be correct. Their assumptions to be correct. So they discovered the two types of electricity, which is uh, one which is negatively charged, and the other one which is what? Positively charged. And they came up with this phenomenon which says deux corps chargés d'une électricité de même signe, positive or negative, c'est repulsé. So they are saying that if you have two bodies which have the same sign, if it is positive, positive, you see that there will be repulsion, repulsé. That's the word, repulsé. Par contre, il s'attirent s'ils portaient des charges de signes contraires. So I'm saying that it attracts each other if they have different signs. If I get a positive and a negative, I'll see that there will be some attraction between these two. So that's why they brought, they came up with two types of I can say electricity, which is the negative electricity resinus, and the positive electricity vetrus. So here, yeah, just talk a bit. Here, they didn't know that which one is positive, which one is negative. They just know that there's an attraction somewhere, but we don't know what really happens. Is there a positive or a negative? So for like under the first part where there's the first part which we talked about, which is the electrization par frottement, they never really knew the charges. But here they discovered the two types of what? The charges, which is the negative and the positive. So I don't know if there's any question here. So basically, they are just the things which you already learned. So I'm just doing a rappel. Yeah, I'm just reminding you guys, because this is important for you to know. This is really important for you to know. This is really important for you to know. When it comes to electricity, you have to know what happens when a plastic, you rub a plastic, you see that the charges remain stationary. So those basically are the things which are going to look at electrostatic. Electrostatic, you are just going to look at the charges which are stationary, which doesn't move. Then for the one which deals with the quiver metal is the electricity, for example, the one which moves in a circuit, and that one I think is really simple, because you have done it secondary. Unfortunately, for that one, for the circuit one, you removed it. Yeah, won't do that one. I don't know if there's anyone with any question here. Any question? Yeah. So if there's no one, we're going to continue. So there are autre mode d'électrisation. There are other ways in which we can do electricization. Electricization, when I'm talking about electricization, is making something to be electrically charged, making something to be electrically charged. How can you make something to be electrically charged? So there are other ways. There are other ways apart from the scrubbing part or what. There are other ways which I can make something to be electrically charged. So the first one is electricization by influence. So electricization by influence actually is you make something to be you make something to be electrical charge by not touching that thing. You just there's an influence when you I can say we influence people by not uh, I can say by not being in contact with them, but by them seeing how we behave, our characters, all those things. That's how we influence. It's the same thing here in electricization. Electricization by influence is the how can you charge uh, an element? How can you charge an element without making an influence, without making a contact, without touching that thing? How can you charge an element without touching that thing? So le charge par influence est un charge sans contact qui provient de la dissociation des charges positifs et négatifs d'un conducteur en présence d'un autre conducteur chargé, phénomène de polarisation. So when I talk about polarization, ici, you making a component to be charged or an element to be charged without touching it. So how do you do it? So first of all, you are going to get a boule de polystyrene couvert par un material conductors. So I'm going to get a ball, it means a ball which is a conductor actually, a ball which is a conductor of electricity, and if this ball, which it means this ball, it is made in a sort of a metal because it's a conductor of electricity, then I'm going to get what? A tige en verre électrisé. So I'm also going to get a tige, a rod, a glass rod, which I've already rubbed and it is charged. So what am I going to do? So I'm going to move this glass rod near to my ball, which is charged, which is a conductor, and a conductor which is neutral. Neutral meaning it has equal number of it has what equal number of what um, it has equal number of electrons and equal number of what no, it has equal number of charge positive and equal number of charge what negative. So I'll try to imagine I'm trying to bring this rod closer to this metal ball. So what happens is when I'm bringing it closer to this metal ball, imagine we have said that we said that a glass is charged. What is the charge of a glass? If those who are following, we said the charge of a glass is what? The rod, the verre.
Positive.
Yeah, the charge of is positive. So yeah, yeah, correct. Yeah, the charge of the glass is positive. So you are bringing a charge of a glass, which is what positive, and you have a ball, which is a metal, which is neutral. It has equal number of what? Positive charges and equal number of negative charges. So if I remember, we said that a conductor basically the charges they move. A conductor basically what charges there's a possibility of what the movement of charges. So when I'm bringing this is a diagram here. If you see the diagram here, when I'm bringing the glass rod near, which is positively charged, I'll see that there will be movement of what the negative charge. You see here that there will be some movement of what negative charge, which will be drawn closer to towards the what towards the glass rod, and there will be the movement away movement of what the positive charge, because a verre is positively charged. So you see there will be a repulsion of the positive charge. So you see that there'll be at the end here, at the end of the what? If you see the ball here, at the end of the ball here, there'll be more negative charges than positive charges, because the positive charges will be pushed far away. And if there's negative charge and positive charge, you see there's an attraction. So you see that this ball will be charged negatively at one end, and you see that there will be an attraction. So in other terms, you see the ball being charged. The ball will be charged in such a way that it will have high negative what? Um, it will have low negative charges than positive charges, and yeah, this side will have more negative charges than positive charges, and you see that it will be attracted. That's why you're seeing that it is moving from here to the next step here. So that's how you do the electrolization by influence. They making something electric by just doing the influence, by not touching, but by just creating an influence where you know that the positive will go away because the glass is positive, and the negative will be drawn. In the case of a bonnet, you see that the bonnet is negatively charged. You see that the positive will be attracted, and the negative charge of a ball will be will be displaced far away. So you see there will be also an attraction. So here they're saying seul un conducteur peut être chargé par influence puisque ces phénomènes proviennent de la mobilité de ces charges. So they are saying here that only a conductor can be charged by influence. If I get a bonnet and a verre, I bring them. If I get an Ebonet there is charged what Ebonet is uh, yeah, if I get an Ebonet which is not charged, or I can say neutral. Now, when I say neutral, meaning they have equal number of positive and negative charges. An Ebonet, a plastic a plastic rod which I have not rubbed, which has no charge, actually is neutral, and a verb which have not rubbed, which has a charge which is actually neutral, the equal number of positive and negative. If I bring them together, you see that there will be no attraction. The attraction only comes in when I rub both of them. That's why I was really emphasizing on rubbing the two things, the two metals before you bring them together. Because if you don't rub them, there won't be any attraction. Since the equal number of electrons and the equal number of what positive charges and negative charges, and positive the other one also positive charges and negative charges, and these charges cannot really move. Unlike a conductor, it can be a neutral, which it can also have the same number of positive and electrical charges, but if you bring it closer to something which is charged, you see that there will be some movement of what the charges. There will be some movement of charges where you see that there will be a positive charge, which if you are using a glass, there will be a positive charge which will move away, then a negative charge which will cause the attraction. So this process of influence, it only works where the charges can move. It cannot work on non-metals where there's no movement of charges, because for non-metals it is only charged by rubbing, and when you rub it, what usually happens is you just get you just get some like I can say you just get some charges from the floor. Yeah, like if you're rubbing it on the floor, there will be just some charges. You see that maybe for example of a plastic, you get it will be more charged negatively because you add some negative charges there. Yeah, that's what usually happens. But there's in the e-bonnet, in the plastic, there's no movement of the charges. So this one for influence is only used with the conductors, those which can have the movement of charges. I don't know if anyone has any questions here before we move on. Yeah, so if there's no questions, So I'm going to go to the other method is electric. Yes, you can ask. Hello. Hello.
I was asking if you can just go through, if you can quickly go through again. I had lost network.
Oh, okay. So here, yeah, I'll just go through quickly since we don't have time. So here we have, I said that there is electricization by influence. This electricization by influence, it only is a method of making an element to be electric charge by just doing an influence. When I say influence, there is no contact involved, but by bringing just two metals or no two elements together, not metals, not a good term, two metals together, by bringing two metals together, and you see that by bringing two elements together, you see that there will be somehow an influence and there will be an attraction which will be induced. So what I talked about was if you see here, there's a glass rod and a ball. This ball is a metal and the glass rod. So when I bring this metal close to, when I bring this glass rod close to the metal, you see that as we said earlier, we said that the glass is charged positive, and this metal, imagine this metal, this I can say this ball metal is charged neutral. So when I bring it close to this metal, you see that the negative will be attracted and the positive will be placed far away. So you see that this ball will be charged, and you see that's why you see that there will be this side will be charged negative, this side will be charged with positive, and you see that the side which is charged negative, it will be attracted to the glass. Yeah, it will be attracted to the rod glass. Then yeah, that's what I talked about. Then I also said that this kind of making an element to be electric charge is only with what with a conductor. It can only be done with what a conductor. A conductor is something which allows the charges to be moving, the electric charges to be moving in such a way that you see that the negative at the place, the positive, maybe the negative are attracted, the positive at the place. So you see there will be some movement of what of charges. But if I get a non-conductor, for example, if I get a verre which is charged and a verre which is a glass, I can say so, a rod glass which is charged and a plastic which is not charged. I'll see no attraction there because there'll be no movement of electrons. They cannot be displacement of electrons. They cannot be displacement of what positive and negative charges because a bad conductor, for it just keeps the charges on one place. So this one by influence is only where it only works with what metals where you can see the movement of charges. Don't know if it's clear.
We say clear.
Okay. So then there's also another method which is electricization per contact. So electricization per contact basically is the same one with it's the same one with the influence, but this one you see that the verre comes closer, it comes in contact with the ball. When the glass, here you see that the glass comes in contact with the ball. So what happens is you see that at first there'll be an attraction. When there's an influence, there'll be an attraction, but immediately this glass comes closer to the ball, there'll be some movement of there'll be some movement of electrons. No, there'll be some movement of the charges. There'll be some movement of the charges in both cases in such a way that it will form something like an equilibrium in a metal. So you see that the positive charges which are here at the end of the glass rod will be lost to the ball, since the ball has got the negative charges, and you see that the positive and the negative charges will be equal, and when they are equal, you see that this ball will become a what? It won't become a, there won't be an attraction, because there are equal number of the positive and the negative charges this side, and you see that there will be a repulsion. There will be the ball will become neutral. There will be a repulsion, and you see that the ball will detach itself from the rod. So that's why you see here that it has now detached itself from the rod. So basically, by contact, when you do contact, what you should know just is there will be some movement of positive charges, or some movement of charges into a ball, and it will create I can say the ball will become, it will have the same number of the positive and negative charges, and you see some kind of repulsion, or you see that there will be the glass rod and the ball will separate. Yeah, so basically that's what it's talking, like these notes here. That's what they are just explaining. Yeah, they're just talking about the expulsion, or that there'll be attraction first, then there'll be repulsion. I don't know if there's any question here. Any question? So yeah, so it's just the same thing, but here just the same thing with fluence, but here you do, there's a contact which is done. So here we're going now to go on charge electric. Yeah, since we have already talked about charges, we have discovered that there is a positive and a negative charge. There's a positive and a negative charge. So this concept, we're going to begin with the concept of the charge electric. So the concept of the charge electric, it all began with Charles Augustine Coulomb and Joseph John Thomson. So if you want to know their history, you want to know more about them, you can just Google them. Then you read about them. Yeah. So Charles Augustine Coulomb discovered the concept of the charge electric. So it was Charles Augustine Coulomb who discovered the charge electric, and Joseph John Thomson who discovered the electron in 1881. So le charge électrique qui caractérisait le phénomène de l'électrisation ne peut être dissocié de la matière. So here they're just saying that the charge electric, which characterize the phenomenon of electricization, the phenomenon of making something to be electric charge, cannot be associated from matter. You know that a matter is basically made up of not matter, a material. A material basically is made up of atoms, and atoms are made up of nucleus, nucleus and electrons. So the nucleus is the protons, the neutrons. Yeah, nucleus is made up of the protons, the neutrons, and you have then around the nucleus you find that they are what? The electrons. These things I think you did them. So it continues here saying il existe sous deux formes, des formes, qualifiées de positive et de negative. So there are two forms of charges, which is positive and negative charges. I think this one you know very well. Des charges électriques de même signe, positive or negative. So they're just saying that if you have two charges of the same sign, if it is positive or negative, they will repel. There will be an repulsion. But if you have got two charges which have which are different, you have what? Some attraction at the right. You have some attraction. So yeah. So basically, that's a bit. I can say a small history about the charge who discovered the charge. It was Charles Augustin Coulomb, which is, I think, is not really important to know. For us, our main goal is how to what really is a charge. That's our main goal. So here we're going to, I don't know if there's any question. I believe there's no question here because it's just positive and negative. But if there's any question, yeah, stop me so that you can ask your question for here. Yeah, so if there's no question, we're still on charge electric. So we've started looking at a charge now. So we're still on charge electric, and you are saying that we cannot talk about a charge or we cannot talk about electricity without looking at a material first. So here we're going to look at the electrization and the constitution de la materia. So here just the electricity part and the what does a material, what is we're also going to look at what a material is made of. Yeah, what a material is made of. So here we know that the material is made up of an atom. That's why you're saying here, this is an atom containing un noyon. Noyon is a nucleus situé en son centre et des électrons qui tournent autour du noyon. So it's saying that an atom is made up of a nucleus which is situated on its center and the electrons which turns around the nucleus. Then it continues saying, le noyon contient des nucléons. So when I talk about the nucleons, they're saying the nucleus contains the nucleons, and when we talk about the nucleons, we talk about the protons and the neutrons. Then here they're saying il y a exactement le même nombre d'électrons et de protons dans un atome. Un atome est donc électriquement neutre. So they're saying there is equal number of the electrons which are negative charge and the protons which are positive charge in an atom. And these, I can say this, because of this, we see that our atom on itself, when you have an atom on itself, which has equal number of protons and electrons, it is neutral or neutre. Neutre, it means it is neutral, it has equal number of protons and electrons. So it cannot do the attraction, all those things. It cannot do those things. For it to do those things, it means one of them has to be more than the other. It's either the protons are more than the electrons or the electrons are more than the protons. So it's just the same phenomenon with the electricity, the negative charge and the positive charge. For a material to be positively charged, it means there are more positive charges than the negative charges. For a material to be negative charged, it means there are more negative charges. There are more negative charges than positive charges. So these ones are the charge electric. This one is not really important. I think you did this in your atomistic. Those, yeah, I don't know if all of you are doing atomistic. So the charges electric, these ones you just have to know them by heart. They never change. So for an electron, it is charged negative 1.602 times 10 to the power negative 9 coulombs. A proton is charged positive 1. So you see that the charge of an electron and the proton is just the same. The only difference is that electron is negative and the proton is positive. Then the charge of a neutron is 0. That's why when you're talking about charges, it's only the proton and the electron which defines the charge of an atom in general. Yeah. So here I can say just a quick rappel. Yeah, a quick rappel on what on the constitution of the constitution of the matter. So you know that material actually is it is made of electrons and protons. Electrons, protons, and neutrons. So I don't know if there's any question. I think this one is just some rappel. That's why I was saying today is just a rappel, and that's why I was saying this topic is not really difficult because there are things which you have done in Zambia. There are things which you have done in Zambia. So this is what I was talking here. I was talking about here under for an atom to be charged. So if you see the first atom here, you have equal number of what? There are 1, 2, 3, 4. There are 4 what electron. Then there are 1, 2, 3, 4. There are 4 what proton. So this atom is what? Neutral. You see, neutral because why? Because it has 4 protons and 4 electrons. So yeah, it has 4 protons and what? 4 electrons. And when you see the next diagram here, the next diagram you have how many electrons? 1, 2, 3, and the protons were 4. So this atom is what? Positively charged because they are more positive. They are more positive what? There are more protons than the electrons. Yeah, there are more positive charges than negative charges, electrons than the protons. So you see that it is a positive charge. Then when you see this one, they have 4 protons, but there are 5 electrons. So there are more electrons than the protons, and this makes it what it will be, and to be what? Negatively charged. So basically, when you are talking about positive, negative charge, that's what you should do. Always be having in mind one is more than the other. Is it the positive, the negative? That's what should always be going into your mind. That's that's the knowledge which you should be having in your in your mind. Then here they are saying le charge total du noyau, or other terms nucleus, est positive Z, and say the two electrons negative ZE. So these symbols, when you see a positive Z and electron, then I'm asking for the charge total of a noyau, a nucleus, and the negative Z. You should know, like if you see a negative Z with an electron, you should know that I'm asking for the charge of what? Electron. Those are the symbols which basically they use most of the times. And here down they are saying électrisation résultait d'un transfert ou d'un déplacement des électrons. So here they're saying that for me to make a material to be electrically charged, it is done in 2 ways. It can be done either by transfer or by displacement of what? Electrons. Transfer, it means when I transfer, meaning it has lost some electrons, or it has what? Displacement, when I say displacement, it has maybe gained. Transfer can be gaining or losing electrons. Yeah, transfer or displacement of electrons. So if you see here, if you're not here, this one had lost electrons. So if you're not here, there will be there's only the change of electrons. There are same number of electrons and protons. Here it has lost electrons. Here it has gained some electrons. So you see here that it's only involved with what? The electrons. When we talk about it, yeah, when we talk about an atom, it involves mainly the movement of electrons. Then the isolo, when I talk about isolo, it means the non-conductor, the isoelectric or dielectric, the verre, resin, matière, plastique, those are non-conductors, ne comptent que the charge layer. So they are saying that the non-conductors, they only have charges which are on one place. Like when you form their charges, you cannot see the movement of charges. As I said earlier, non-conductors, there's no movement of charges. That's why you cannot. It's really impossible for you to create a electricity with a non-conductor. That's why you have seen most of our pots, they are made of plastic. The handles of our pots, they are made of plastic, and yeah, and a lot of things which they are connected with electricity, they are made in a sort of a plastic, most of them, because they know that there a charge cannot pass through a plastic, a wood, those things. Yeah, because they know that they are bad conductors. Then, a conductor, which is a metal. In a conductor, which is a metal, les électrons peuvent se déplacer facilement. So they are just saying that in a conductor, which is a metal, electrons can move easily. So you can see the movement of electrons, and when there's a movement of electrons, that's where now you create electricity. That's where you see the electricity which you have here, because basically most of the time they use conductors which can allow the movement of the charges, the movement of electricity. The movement of electricity. And that's it. And I would also want you to do something like today. Just try to you get your pen, you try scrubbing your pen down. Just try to scrub your pen down. Then you try opening the tap. After you have scrubbed it down, try opening the tap. Then the water should only be affiliated. The water shouldn't be. I can say it shouldn't be coming out a lot. Just like I can say it should be just some little water, like some drops. Some drops, or it is flowing but in a small quantity, and it is flowing in a small quantity. You should try it by it's flowing in a small quantity. So what you should do is try rubbing a pen, and bring this pen close to the water, the fillet of water, the small flowing of water, not a large quantity from the tap. When it's flowing, just open it a bit where there's a small flowing. Then you see that there will be some repulsion. There will be some repulsion. You see the phenomenon of what charges. You see that a charge will be created on a pen, and there will be some sort of repulsion. Since you know that water is a feeble conductor of electricity. Water is a feeble conductor of electricity, meaning in water there can be some movement of charges. There can be some movement of charges, but at a small quantity. That's why you have seen if it's not advisable to touch electrical appliances with water, because it can easily cause some shocking. It can easily cause some shocking, all those things. So you should try that one. You see if it will work. But basically most of the time it works. Any question here? Any question before we move? So basically just a repair. I'm just reminding you the things which you already did in atomistic, but here we're talking it in terms of electricity, in terms of what charges. So basically this topic, if you should develop an interest, it's really an interesting. You learn about those who want, especially those of you who wants to do electrical engineering, those who wants to do my electrical engineer, but my engineers, you should have an interest in this topic, because it is the heart of it's the heart of the engineering. Those who want to do electrical engineering, it is the heart of it. If you know this one, then you love you have some curiosity on electricity, and you want to find more on it. So here we are going to continue under quantification de la charge électrique. So here it's not really important. These things are not really important. So what you should only know here is that les charges d'un système ne varient pas de multiples entiers d'une charge élémentaire. So here they're just saying that what you should only know here is the charge elemental. The charge elemental is I can say is a charge which is I can say which defines basically which defines the I can say the electrons, I can say the charge which is an average charge between the two, the proton and the electron. So it's the charge elemental, but this one is not really important for you guys. But you should just know that the charge elemental, which is denoted by E, is equal to 1.6 2 times 10 to the power negative 9 columns. Yeah, there's no, there are no signs here. There's no positive or negative, unlike the one where we have the protons, the electrons, and the neutrons, where I say that the protons is positively charged, the electrons is negatively charged, positive 1.602, that's the protons, negative 1.602 times 10 to the power negative 9, that's the electrons. So yeah, so when you hear charge elemental, basically it is represented by what? By this formula. That's what you should just know here. Yeah, it's not really something which we have to really spend a lot of time here. Then, yeah, then there's also this formula. If two comps posséder une charge Q, K, on peut écrire. So they're saying all the what? All the I can say all the material or all the body, they have a charge which is denoted by Q. So most of the time when they tell you to calculate a charge basically is denoted by what? The Q. And it's equal to K, which is the number of charge in a comp. How many, the number of charge, you have to know the number of charge. And E is the charge elemental, which is this formula here. So basically this formula is not really used. Yeah. So I can say it's not really important because it's not really used. There are formulas which are used, which are important. Yeah, this one you just have to know that Q is equal, the charge can be denoted by K, which is the number of the charges in a comp. Yeah, the number of charges. Is it, you count the number of positive and negative charges, and yeah, the number of positive and negative charges in a comp. And E is the charge elemental. Then here down they're just saying you should only know that, you should know that if a body loses electrons, it is positive. And if a body receives electrons, it is charged what? Negative, because there will be more electrons. If it loses electrons, it will be positive because there will be more positive charges than the negative charges. Yeah. So I don't know if there's any question. If there's any question, please stop me. Is everything clear? Can you get me clearly?
Yes.
Oh, okay. Yeah, so basically, I think, yeah, so I think this thing, I think it's just a rappel, just reminding you. So that's why I think you're not finding any difficulty. So we're still on charge electric. So we've talked about the positive, the negative charge, how to make a material to be charged by influence, which is not by contact, by also by contact, where we bring them into contact. I've talked about those things. And there's other thing which you have to know, that the charge electric, the positive or the negative charge electric, is never formed, but they follow a conservation de la charge electric. You know that if I remember correctly, we had learned in secondary, we had learned about conservation of energy, where energy cannot be destroyed or created, but can be transformed from one form to another. I think that's the definition, if I still remember. Energy can never, the conservation of energy, the law, the conservation of energy, or the law, the conservation of energy says that energy can never be destroyed, but can be formed from, can never be destroyed or created, but can be transferred from one form to another. What do I say? The potential energy transformed to kinetic energy, then you go on the other form of energy, the heat energy, those things. So we see there that it's the same thing with the charge electric. The charge electric, you can never create a charge electric. On ne crée pas de charges, on ne peut pas détruire des charges. On ne fait que les transfert d'un corps à un autre. So here, that's what I've seen here, is saying that on ne crée pas de charges. We do not create the charges. On ne peut pas détruire the charges. We cannot destroy the charges. On ne fait que le transférer d'un corps à un autre. We can only change it from, we can only transfer it from one corpse to another. For example, when I rub my my plastic, my ebonite plastic, or yeah, my ebonite, which is plastic, or if I rub my glass, you see that there'll be I'll create something. You see there'll be there is not pardon me, not creating. You see there that uh, there's nothing really which is created, but what happens is you see if in a case of a glass rod, what happens to a glass rod is when I rub it down, it will attract the it will attract the positive charges which are on the floor. So there you just see that it will be some movement of what the positive charges towards the glass, and the glass will be what positively charged. There's no creation of charges. Charges are always there. That you should know that charges are always there. It's only the transfer from one material to another material. That's it. Charges are always there. So you can never create charges, you can never destroy charges, but they are transferred from one form to another. The same thing with energy. You can never create energy, you can never destroy energy, it just transform from one form to another. So here is the same thing here. They got something which is charged positive and something which is charged negative. Then no, they I can say they got a rod, yeah, a rod, which is after they rubbed it, it was found to be charged positive, and the other part which they were using, it was found to be charged but negative. So you see here that there's no creation of charges here. Is the only thing which is happening here is that this part uh, uh, the what I can say, it looks like a plastic thing, which like a cloth, a plastic cloth, which he used with rubbing. You see that uh, it when they rubbed them together, it lost the positive charges to this rod, and when it lost the positive charges, it means this plastic cloth, it became negatively charged, because it had now more negative charges than the positive charges, and the rod which was neutral, it now became what positively what charged, because it accepted the positive charges from what from the plastic cloth here. So you see there that there's really no forming of the charges. The charges are just moved, they just transfer from one material or one corpse, one body to another. I don't know if it's clear under conservation of energy, conservation of the charge electric, not energy, conservation of the charge electric. Is it clear? I need an answer.
Oui.
Oui.
Is it clear?
Oui.
Okay. So basically, the same thing which you did, conservation of energy, those things, yeah, it's the same phenomenon with the charge, the conservation that are charge electric. Then charge electric, we're still on charge electric. So we have talked about, we have talked about the types of charges which you have, which is positive and the negative charges. We have talked about those things, and right now we're going to look at the distribution of charge electric. So there are some times where you when you're looking at the charge electric, I want you to get me very close to this, because this is the thing. I think from the secondary, from here, they added some things. Yeah, they added some things. So when you have, where did your secondary, like your secondary, it was a bit limited, but here there are some things which was added. So yeah, so you have to get me clear on this one. So here, when you say what usually happens when you say distribution the charge electric, we know that the charge electric can be defined in two ways. I can say it can be found in two ways. Yeah, there's where you are able to I can say they will give you a diagram where they specify that here there's a charge positive, there's a charge negative, there's a charge positive. It will be a sort of a diagram where they specify. I can say you can see the charges that you can see. You can see the charge that this one is positive and this one is negative. But there are some circumstances where you have what I can say you have a material, and on this material there is what distribution of charges. There are a lot of charges. How can you be able to calculate its volume, the density? How can you calculate its density or its volume? That's what we're going to look at under distribution their charge electric. Distribution their charge electric is the density of the electric charges. When electric charges a lot of charges are found on a same place. I can say there's a quantity of charges which are found on a same place, which you yourself cannot even count. That one, there is a formula which you have to use to find the charge. You cannot. It's different from when you know where the charge is. When the charge has been given to you, like you are going to understand more when you go to the individual. When you go down, they also talk about when you are dealing with individual charges. What do you do when you're dealing with individual charges? That's where you're going to understand more. So here we're going to do with it. There is a cloud of charges or a density. When I say density, meaning things are clouded. Like if it is denser, here density, I'm not talking the density in form of the weight, the what. When I talk density here, the density charge, I mean the cloud of a charge where there are more charges. In other terms, I can say these charges, they are a lot in such a way that you cannot count, and they are found on the same place. That's what it defines density their charge. So when you talk about density their charge here, they're saying that density the charge electric désigne la quantité de charge électrique par unit de space. The quantity the charge electric per unit de space. So it's the number of charge electric. The density the charge is a number of charge electric at a unity space, at a space which is given. So you have been given a space, and they ask you what is the quantity of the charge. What is the quantity of the charge which is distributed maybe on the surface of on this surface, or on the volume of on this volume. Like they give you a volume, a cube, for example. They tell you what is the distribution of a charge on this volume. You have to know which form you have to use. If they give you something like a cube, and they also ask you what is they get the top face, then they say what is the distribution of charges on this surface. You have to know how to calculate the distribution of what charges on surface. So basically, the most important thing is you knowing the formulas, which formula I have to use to calculate the density, the density volumic, or the density surfacic, or the density linearic. So for density volumic is the volume. If you want to calculate the number of charges in a given volume, which formula can you use? So they are saying here, soit un volume dv which is greater to 0, dans ce volume on trouve la quantité de charge, which is dq, the density volumic, their charge, sera. So here they are saying that if you are given a certain volume, and there in that volume there is a quantity of a charge which is defined by what? dq. the formula of the density volume is, you see this is rho c. Rho c, it means this is what you'll be using to represent the density volume, is equal to the quantity of charge dq divided by dv. dv is the volume. So dv here, that's where now it comes to the volume. That's where now you are going to see the importance of coordinate spheric, coordinate cylindric, coordinate polar, coordinate Cartesian. That's where you're going to see the importance. So they can give you a sphere, and you know how the formula for the volume for a sphere. You know its formula for a sphere. Or example, they can give you a cylinder. Yeah. So for example, I can give an example of a cylinder. A cylinder, they say they can give you that there's a charge which is distributed on a cylinder. Calculate its density volumic. So for you to calculate its density volumic, you have to know the formula for the volume. So dV, you know the formula for the volume for a cylinder is what? Rho d rho d theta dz. That's the formula for volume. If you check your volume, the volume, so that's the formula for volume. So that's what you're going to, so that's where it all comes in now. That's where it all comes in, the formulas, the what. That's why now you're going to start playing with what? The formula. So it depends which shape they have been given you, and you see that shape, you see which coordinates you have to use, and you use it using the what? The formula. So basically, like they can give you the charge sometimes, the volume. You have to do some differentiation. Like for this topic, actually, we don't usually find the actual answers. We just find the formula. So electricity is only it only deals with finding the formulas. You want they don't usually give numbers like you to find the actual answers. No, they don't usually do that. You see, you finding the formulas. So for density volumic, basically, for example, you are given a certain surface, then they tell you that the charges occupy this certain volume, which you don't know. So then, and they ask you to calculate its density volumic. This is the formula which you have to use, depending with the form which they have given you. Is it spheric? Is it cylindric? Is it just a circle, or is it what you have to see first? You have to verify. So first thing is verifying what shape have you been given. Yeah. So I don't know if there's any question here under density volumic the charge. Is there any question? So basically, this formula, you just have to know it by heart, and most of the time they ask you to find the charge most of the time. Then if finding a charge is just dq is equal to rho dv. Then your dv, you know how to come up with your dv with the coordinate. You know, you just go on, if it's coordinate spheric, just go on coordinate spheric, you check its formula for calculating its volume, then that's what you replace here. Don't know if there's anyone with any question. Any questions?
Yeah, that's an equal sign.
What?
That's an equal sign with three lines.
Yeah, it's basically, it's just an equal sign. They made there's a mistake. Just supposed to be just 2 lines. Yeah. So so this one just have to know the formula, and you just know that the most of the time they specify the density volumic, the charge, you know which formula you have to use. Then there's also there's also density surfacing the charge. Density surfacing the charge, they tell you that calculate the density surfacing their charges. They'll tell you that calculate the density surfacing of charges. And this one also, this one also is it is presented by the surface. If you see here, there's this surface, then there's dq. This surface and a dq. Then this one is just the symbol for density surfacing. Yeah, the symbol for density surfacing. So you have like for density volumic, you use this symbol which is in the form of a rho. Then density surfacing, you use this symbol. Yeah, I think this one is in the form of omega. Yeah, if I'm not mistaken, it's omega. So it will be, you have to know this one. Omega is equal to dq over ds. Then it depends how they have asked you the question. They'll ask you find the density surfacing, their charge. So it's basically you finding the density of, for example, this is a surface. You just find a density, a certain density of, like a certain on a certain area, on a certain small surface where there are a lot of charges. So this is just showing the distribution of charges here. Then the formula is dq over ds. Your s, your dq, they'll give you the charge. Your ds, basically your ds is what surface is it is a surface for which shape? Is it cylindric? Is it spheric? Is it a polar, just a circle, or is it Cartesian, for example, square, a cube, a what? So just you have to. That's how I was saying. The coordinate part is the one which is the most important part, because these ones you are just going to be using the same what, the same formulas, the formulas which you did in coordinates. Yeah, the same formulas which you did in coordinates. So if you know the formulas in coordinates, you won't have any difficulties with this part, because they will ask you the distribution of surfaces, those things. Yeah, I don't know if there's any question here. And each unit is centimeter per meter squared. Yeah, if you check this one, you see no columns per meter cube, column per meter cube. This is volumic. Then for surfacing is column per meter squared. That's easy units, like when you find your answers. So if you do questions, that's when you even understand them more and more. Yeah. Then there's also charge linear. This is the linear the charge. So this one is meter. Say column per meter. So linear basically is the charge which is distributed just on I can say on a line. A charge which is distributed on a line. It's not on a surface. For example, so we have started from a volume which has got a lot of surfaces to form a volume. Then there we have broken it down to a surface. Then from there we have broken it down to a what? Just a line. So sometimes, for example, they can draw you a circle. You know, a circle is a form. That's a line. If you see a circle is a line, and they tell you that there are charges which are distributed on that line. Then you know that you are using what? If they tell you to calculate the density, you know that they are just asking you to create what? To just calculate the density linear data charge. And you should always know that the density is always the same at wherever you choose to calculate it from. If you want, you can calculate from here, it's just the same. The density is just the same. And you use the same what? Formula. So there will be lambda. This is called lambda. Lambda is equal to dq over what? dl. Dq is the charge they usually give you. Then dl is the displacement. Basically, most of the time, the density linear, it uses the ones for coordinate polaire. Yeah, so dl is basically the one which you use to calculate I can say the one which you use to calculate the surface of I can say the surface of or in other terms, the one which you use in coordinate polaire. For example, in coordinate polaire, we have rho, we have d rho, and what, and rho, d rho, and theta, d theta, and that's what defines coordinate polaire. So coordinate polaire is like it's only for circles, and the dl actually is when you're told to calculate the surface of, it's just the same with the formula for the surface of what the coordinate polaire. Since we know that coordinate polaire, there's no volume for coordinate polaire, it's only the surface. That formula for the surface is the same one which basically we use rho, d theta. But they specify, for example, if they say the radius is constant in a circle, it means you only have rho, d theta, because the d rho, it will give you what? 0. So those things, I think when you come to do exercises, you understand them even more. Like when I talk about the DL, which is basically the surface of a line. Then the dq is a charge. Then the lambda is the density. Then the symbol for density, what? The name. So this formula also, you have to know it by heart. You have just to have it by heart. I don't know if there's any questions here. Any questions? Is it clear, or is everything clear? I need an answer. Is everything clear?
Yes, very clear.
Okay. You want to ask something? I heard someone wanted to. If you have any question, don't hesitate to ask. Yeah. So we're going to continue. Yeah, I think this will be our last part before we start with the column. Yeah, the first of the column, I think we'll do it on Friday. Then on Friday, that's when I'll even give you the questions, since there's only a small part which is remaining now for us to finish. Then on Friday, that's when I'll give you the question. And please don't forget to pass through when you're done. Don't forget to pass through, because you know, if it passes a lot of time without you passing through, you won't be able to understand these things. Yeah, because electricity is, you have to pass through. When after just a lesson, you just have to pass through. Just try to pass through fast to relate with what we have done. So charge électrique, we are still on charge électrique. So they're saying maintenant on sait que le charge est une propriété fondamentale de la matière comme la masse. So here they're saying that the charge, we have seen that the charge is a property which is very important, because we have looked at positive and negative charges, and what usually happens, the attraction, those things. We have also looked about the conservation of charges. Yeah, the conservation of charge, where we said the charge cannot be destroyed or created, but is transferred from one material to another. Yeah, we've looked about that, and we have also looked about the quantifier. The quantifier basically is that formula, which I can say is not really important. The Q is equal to K times E, where K here they have just presented it in N, where N is the number of Z, number of what protons, and where N is the number of Z, Z is actually the number of protons and the number of electrons, and where E is the charge elemental. So yeah, then there is a principle, the inertia, the principle, the inertia. I think you remember, I don't know how to call it in English, but in physics there was something like inertial, like when a body is moving. I don't know if you remember this one. There was, if I remember correctly, there was the law was, it was under the second Newton's law, something like that, if I remember my physics correctly. It said that when a body is moving, the body will rest in movement unless an external force is extended on it. I don't know if you remember that one. If a body is in movement, the body will remain in movement unless an external force is applied on it. So the principle de inertia is just the same thing here, which says tout object chargé reste dans l'état de repos or the mouvement uniform. So they're saying that all the objects which are charged remain in the state, which is the resting state, or in the movement uniform, or it continues en ligne droite dans laquelle il se trouvait. So they remain in the constant movement in the straight line in which they are found. Then it continues here saying, à moins que quelque force n'agissait sur lui et ne le contraignait à changer les têtes. Then saying, unless, au moins que, it means unless some force n'agissait, which means acts sur lui, on it, we are going to see the change in state. So the charges also, they act in the same way. All the charges, they remain in their form unless we do some rubbing. That's why you see some charge, there will be some charging, or unless we do some influence with the conductors, where you see there will be the charges can be moving uniform, but when you do some when we do some method of electrolization, we see that there's a force which is exerted, a certain force which is exerted, and we see that there will be some change in the state in such a way that it will be maybe positively charged, negatively charged, those things. Yeah, so basically here, I can say here it was just a small rappel of a small summary of what we have looked at, like the charge electric, what we have looked at. So the most important thing now, we have known what charge electric is. There's a positive and a negative charge. That's what the most important. And we have known how a metal and a non-metal behaves. A metal, you see, there is a displacement of charges, there's movement of charges. In the non-metal, when you create charges, they rest on the when the charges are transferred on a non-metal, they rest on the piece. There's no movement of charges. I think that's all for today. That's all for today. Yeah, so next on Friday, not next week, on Friday we're going to start on force de Coulomb. Yeah, that's what we're going to start on, force de Coulomb. Yeah. Okay. Let me not take more of your time. Have a good day, and yeah, enjoy the rest of your lessons. I don't know, before we go, if anyone has any question you can ask before we cut. You're welcome.